Good morning all. Welcome to the next lecture. In the last lecture, we have defined and discussed the quadratic equation and the factoring method for solving quadratic equation. See, today we will use another method for solving quadratic equation, that is by using quadratic formula. We have already defined the quadratic equation as an equation in which the highest power of unknown variable x is 2, or it is the second degree polynomial equation, meaning the highest power of the variable is 2. So the general form of quadratic equation is, see, it is ax square plus bx plus c is equal to 0, where a, b, c are the constant, where a is not equal to 0. As in the earlier classes as well, we said that if a becomes 0, then this quadratic equation will become the linear equation. That is here, it only remaining bx plus c. So that means it will become a linear equation. So here we are assuming that a is not equal to 0. So here we will discuss how to solve this quadratic equation by using quadratic formula. See, this formula can be derived by completing the squares on the general quadratic equation, which leads to the quadratic formula as a solution for a x. Now we are going to derive the quadratic formula from the general form of quadratic equation, which is equal to ax square plus bx plus c is equal to 0. So this is the general form of a quadratic equation. From this equation, we are going to derive the quadratic formula. See, the first step here, we divide the both side by a, the coefficient of x square, that is a. So this equation will become, see, it is x square plus b by a x plus c by a, which is equal to 0 by a, which is equal to 0. Then after that, we want to move this constant term into the right side of the equation. So we are moving this constant term into the right side, then it will become c minus c by a, minus c by a. Now we want to complete the squares on the left side. We want to complete here squares on the left side. See, for this purpose, we are going to add and subtract the square of half of the coefficient of x in the here, that is b by 2a whole square. So here we are adding and subtracting from this particular part, so that this equation will become, see, x square plus b by a x plus b by 2a whole square minus b by 2a whole square. So we are adding here and subtracting the term, that is b by 2a whole square, which is equal to what is remaining, it is minus c by a. Then after that, we can write the factors for the perfect square trinomials on the left side. See here, this particular term will become, see, it is x plus b to a whole square. This term will be in the form of a plus b whole square expansion form. So we can write it is x plus b by 2a whole square minus what is remaining here, b by 2a whole square is equal to minus c by a. So next we want to simplify this equation by squaring this particular term. So it will become, see, x plus b by 2a whole square minus, it will become b square divided by 4a, that is 2 square a square, which will become 4a square, which is equal to minus c by a. Then after this, the next step is that we want to solve x, especially isolating the perfect square terms by adding to both sides, that is b square by 4a square. So it will become, see, this term will be cancelled out if you add the both side with b square by 4a square. So this term will be cancelled out, and here it will become plus b square divided by 4a square minus c by a. Now in the right hand side of the equation, we take the common denominator. This here, we will going to take the common denominator and multiply and divide the term, that is minus c by a, with 4a. so that we can arrange. So here we will take the common denominator here, it is 4a, and multiplying and dividing with minus ca. So this will become x plus b by 2 whole square, which is equal to b square minus 4ac divided by a square. See, after this particular step, we will again take the square root of both sides, especially remembering, we are going to consider both positive and negative square term. So here we are considering the square root of the both side. So here it is under root x plus b by 2a whole square plus or minus under root b square minus 4ac divided by 4a square. Now see, we want to remove this root. See, if you want to remove this particular root, then what is remaining here? It will be x plus b by 2a is equal to plus or minus under root b square minus 4ac divided by 4a square. Then after this particular step, we want to solve the x by subtracting from both sides, that is b by 2a. b by 2a we can subtract from the both sides so that this will be cancelled out. We can isolate the variable x. So x is equal to taking this minus b by 2a plus or minus under root b square minus 4ac divided by 4a square. Now after this particular step, we want to simplify the expression under the square root. See, we want to simplify this term, especially which is under root. See, we are removing the under root from this particular denominator. So this will become x is equal to minus b 2a plus or minus. See, we are only taking the under root for the numerator, that is b square minus 4ac as it is. So if you remove the root for the denominator, then it will become 2a. Now let us see here, the denominator is common here. We are going to combine, or finally we are going to rewrite this one is more concise form as a quadratic formula, which is equal to minus b plus or minus under root b square minus 4ac divided by 2a. And this is nothing but, this is considered as the quadratic formula. So thus, after the equation has been reduced into the form of ax square plus bx plus c, which is equal to 0, that is in the quadratic general format, we are able to solve the quadratic equation by using this quadratic formula, that is x is equal to minus b plus or minus under root b square minus 4ac divided by 2a. See, this quadratic formula is used to find out the roots of quadratic equation when factoring the equation is not feasible, or when factoring leads to a complex factors. So in this case, if the roots of quadratic equations are irrational or maybe complex, then the quadratic formula provides an exact method to find the solution. See here, if a, b, c are the real number, then the b square minus 4ac, this particular term we can call it is a discriminant. This is the discriminant, and this discriminant actually determines the nature of the roots, that is nature of your solution. See, if the discriminant is positive, that means I am denoting here discriminant in terms of d. So if d is greater than 0, which indicates that the quadratic equations has two distinct real roots, geometrically this means that the parabola represented by the quadratic equation intersect x-axis at two distinct points. So if d is equal to 0, what happened here? See, it indicates that the quadratic equation has two real roots, but they are equal. Or it is repeated. So geometrically, if you represent this particular parabola, then what it will become? The quadratic equation touch x-axis only at a particular point, only one point. Similarly, if d is less than 0, that means discriminant is negative, then it indicates that the quadratic equation has two complex, or it is an imaginary roots, and geometrically, see, it means that the parabola represented by the quadratic equation does not intersect in the x-axis if d is equal to less than 0. Thus, the discriminant is actually provide a crucial information about the behavior of quadratic equation and help in analyzing and solving the problems involving in a quadratic equation. So it allow you, especially to find or quickly determine whether the roots of quadratic equations are real, equal or complex without explicitly finding them. So this is the quadratic formula that is here, minus b plus or minus root b square minus 4ac divided by 2a. Now let us consider some examples so that how can we solve the quadratic equation by using the quadratic formula. See, we have a question here. We want to solve the quadratic equation, that is x square minus 5x plus 6 is equal to 0. See here, the coefficient of a is equal to 1, the coefficient of b is equal to minus 5 and coefficient of c is equal to 6. So we are identified the coefficient. After that, we can directly apply the quadratic formula, which is equal to minus b plus or minus root b square minus 4ac divided by 2a. We know what is a, b, c. We just want to substitute these values here. Then it will become c minus 5. b is equal to minus 5 plus or minus under root minus 5 square minus 4 into a, that is 1 into c is equal to 6, divided by 2a, that is 2 into 1. If you go for simplifying it, then minus will become plus 5 plus or minus 5 square, which will become 25, minus 4 into 1 into 6 divided by 2 into 1, which is equal to 2. So if you go for simplifying it, 4 into 1 into 6, which is equal to 24. So we have in under root, we have 25 minus 24 whole divided by 2. So here we can again simplify it, plus 5 plus or minus, see 25 minus 24, which is under root 1 divided by 2. So root 1 is equal to 1. So 5 plus or minus 1 divided by 2. So x is equal to, we have a two values. One is 5 minus 1 divided by 2, which is equal to 4 divided by 2, which is 2. Similarly, we can consider x is equal to 5 plus 1 divided by 2, which is 5 plus 1, which is equal to 6 divided by 2, which is 3. So this is the solution, that is x is equal to 2 or x is equal to 3. So this is the solution for the quadratic equation, which is x square minus 5x plus 6. Consider another example. See, we have a quadratic equation, that is 5x square minus 55x plus 140, which is equal to 0. Now, we have the coefficient of x square, that is a, which is 5, b is equal to minus 55, c is equal to 140. We can directly substitute these values into the quadratic formula, which is minus b plus or minus under root b square minus 4ac divided by 2a. So we can substitute here, then it will become minus 55 plus or minus 55 square b square minus 4 into 5 into 140 divided by 2 into a. Here it is, a is 5, so it is 2 into 5. We can simplify it. This minus will become plus, so it is 55 plus or minus under root 55 square, which is 325, minus 4 into 5 into 140, which is equal to 2800 divided by 2 into 5, which is equal to 10. Again, we can simplify it. See, 3025 minus 2800, which is equal to under root 225. Then 55 plus or minus under root 225, which is nothing but which is 15 divided by 10. So you can simplify it. We will get a two values. One is 55 plus 15 divided by 10, which is 70 divided by 10, which is equal to 7. And 55 minus 15 divided by 10, which is equal to 40 divided by 10, which is equal to 4. So here also we have x, we have a two values, that is x is equal to 7 or x is equal to 4. So this is the solution for this given quadratic equation. Now let us consider another question. See, we want to solve 75 divided by y square plus y square minus 20, which is equal to 0. So here we want to identify, a common denominator. So here the common denominator is y square. So we want to multiply the both side of the equation by y square so that we can eliminate or we can clear the fraction term. So accordingly, see, we are multiplying the both side of the equation by using y square. then it is y square into this particular ended term, which is equal to 0 into y square, which will become 0. So here y square and y square will be cancelled out. So what is remaining? It is 75 plus y square into y square, which is equal to y raised to the power 4, minus 20 into y square, which is equal to 20 y square, which is equal to 0. Now we can rearrange these particular terms. So we can rewrite it is y raised to the power 4 minus 20y square plus 75, which is equal to 0. See, this is a quadratic equation, the highest power of the variable y, which is equal to 4. So now we want to convert this particular quadratic equation into the quadratic equation by assuming y square is equal to x. See, if we are considering y square is equal to x, then we can write y raised to the power 4 is equal to x square minus 20y square will become 20x plus 75, which is equal to 0. Now we have the quadratic equation. We can now directly apply the quadratic formula. That is, here we know the coefficient of a is equal to 1, coefficient of b is equal to minus 20, coefficient of c is equal to 25. We can directly apply the quadratic formula so that we will get the value of x. So here the quadratic formula, which is equal to minus b plus or minus under root b square minus 4ac divided by 2a. We are directly substituting the value of a, b, c here. Then we will have x is equal to minus 20 plus or minus 20 square minus 4 into 1 into 75 divided by 2 into 1. If you go for simplifying it, minus 20 will become plus 20. Plus or minus 20 minus 20 square, which is equal to 400, minus 4 into 1 into 75, which is equal to 300, divided by 2 into 1, which is equal to 2. We can again simplify it. See, 20 plus or minus under root 400 minus 300, which will become 100, divided by 2. Then root 100, which is nothing but it is 10. So we can again write x is equal to 20 plus or minus 10 divided by 2. So we can have the values for x, that is 20 plus 10 divided by 2, that is 30 divided by 2, which is equal to 15. Similarly, we have x is equal to 20 minus, because it is plus or minus. So it is 20 minus 10 divided by 2, which is equal to 10 divided by 2, which is 5. So our values for x here, it is 15 and 5. So this is the solution for the equation, but here it is, it is y raised to the power 4. So again we want to convert it. Since our y square is equal to x, see, we can solve y is equal to nothing but it is plus or minus under root x. So here the x is equal to 15. If x is equal to 15, then y is equal to under root plus or minus 15. Or similarly, we have the y is equal to plus or minus x, that is 5. So it is plus or minus root 5. So here the solution for this quadratic equation here, y is equal to plus or minus under root 15, and here y is equal to plus or minus under root 5. So this is the solution for given equation. Now let us consider another example. We have a pair of simultaneous equation is given. See, the first equation is x square plus y square, which is equal to 29. And the second equation is y minus x is equal to 3. See, since in equation number 1, see here x square and y square, it is not easy to rearrange. So to solve this system of equation given here, what we will do? We can use the substitution method. See, let us use the substitution method and solve one equation for that. So here the equation number 1, which is x square plus y square is equal to 29. The second equation we are denoting it is y minus x is equal to 3. Now we are going to convert this particular term, equation number 2. See, we solving for y, so that this equation will become y is equal to 3 plus x, because it is minus. So we are adding plus x in the both side of the equation. So it will become y is equal to 3 plus x. Now we can substitute this y is equal to 3 plus x into the equation number 1. So that, see, it will become x square plus, instead of y square, we will substitute it is 3 plus x whole square, which is equal to 29. So here x square plus, 3 plus x whole square, it is a plus b whole square format. So it will become a square plus 2ab plus b square. So it will become 9 plus 6x plus x square, which is equal to 29. So now here we have x square term, it is x square and x square here. So it will become 2x square plus 9 plus 6x, which is equal to 29. Again we are going to rearrange this term, subtracting the 9 from both sides of the equation, so that this term will be cancelled out and minus 9 will be appeared on the right hand side of the equation. So again we are going to rearrange it. It is 2x square plus 6x, then 29 minus 9, which is equal to 20, taking into the left side, so it will become minus 20. So we have a quadratic equation now. Now we can directly apply the quadratic formula, which is equal to, see, this is our equation. This is quadratic equation, and now we are applying the quadratic formula here. So it is minus b plus or minus root b square minus 4ac whole divided by 2a. So we know here a is equal to 1, b is equal to 3, c is equal to minus 10. We can directly substitute these values on the quadratic formula. Then it will become minus 3 plus or minus under root b square, that is 3 square minus 4 into 1 into c. Here it is 10. It is minus 10. It is minus 10, sorry. So here it will become, so it is 4 into 1 into 10, it will become 40. So it is integrated, we can say that it is 4 into 1 into 10, which will become 40. It is wrongly written here. So it is 3 square, which is 9, minus 4 into 1 into minus 10, which will become minus 40. So here minus and minus 40, which will become plus 40. So it will become 9 plus 40, which is equal to under root 49. So here, see, x is equal to minus 3 plus or minus under root 49, which is equal to 7 divided by 2. So we have a two solution here. See, one is minus 3 plus 7 divided by 2, which is equal to, again it is 2. Then or x is equal to minus 3 minus 7 divided by 2, which is equal to minus 10 divided by 2, which is minus 5. So here the value of x is equal to 2 and minus 5. So if x is equal to 2, then what is y? Y is equal to 3 plus x. So here when x is equal to 2, then y is equal to 3 plus 2, which is equal to 5. And if x is equal to minus 5, then y is equal to 3 minus 5, which is equal to minus 2. So in this way, we can solve this pair of simultaneous equation. Now let us consider another example. See, we have an equation 1 by x minus 3 plus 1 by x plus 5, which is equal to 1 by 3. See here, we want to find a common denominator. So here the common denominator, see, least common denominator here is x minus 3 into x minus 5. So we are going to multiply the both side of the equation by using the LCD, that is least common denominator. So it will become x minus 3 into x plus 5 into 1 by 3 plus again we are multiplying with the second term, that is 1 by x plus 5. Again with the right hand side of the equation, again we are multiplying the same LCD. So here we can cancel out x minus 3 will be cancelled out. What is remaining? 1 into x plus 5, which is equal to x plus 5. Here x plus 5 will be cancelled out. What is remaining here? It is 1 into x minus 3, so it will become x minus 3. Then here it is x minus 3 into x plus 5 divided by 3. So if you go for simplifying it, then we can write, see, by removing the bracket, x plus 5 plus x minus 3, which is equal to x minus 3 into x plus 5 divided by 3. Now we can multiply the both side of the equation by 3, so that we can remove here the 3. So it will become multiplying the both side by 3. See, it is 3 into x plus 5. See here, the x plus x, which is equal to 2x. Then 5 minus 3, which is equal to 2. So we are multiplying this side with the 3. Again we are also multiplying the right hand side of the equation with the 3. So this 3 will be removed. The denominator will be removed. So what is remaining here? It is x minus 3 into x plus 3. So now we can multiply here with the 3. So it will become 6x plus 3 into 2, which is equal to 6. Then here we are multiplying x into x, which is x square, x into 5x, which is plus 5x. minus 3 into x, which is minus 3x, then minus 3 into plus 5, which is equal to minus 15. See, if you go for rearranging this particular equation, then it will become x square plus 2x minus 15 minus 6 is equal to 0. So again, we are simplifying this equation, then it will become x square minus 4x minus 21 is equal to 0. So we have a quadratic equation right now here. So we can solve this quadratic equation by using the quadratic formula. So here a is equal to 1, b is equal to minus 4 and c is equal to minus 21. So here we are substituting all these into the quadratic formula. Then we can simplify it minus 4, which is equal to plus 4 plus or minus, see, minus 4 square, which is equal to 16 plus 4 into 1 into minus 21, which is equal to plus 84 divided by 2. So we can simplify it again. 4 plus or minus 16 plus 84, which is equal to under root 100 divided by 2. So which is equal to 4 plus or minus 10. Root 100 is equal to 10. So it is 10 divided by 2. So we have a x value which is 4 plus 10 divided by 2, which is 14 divided by 2, which is 7. Or x is equal to 4 minus 10 divided by 2, which is minus 6 divided by 2, which is minus 3. So our x value is equal to 7 or x is equal to minus 3. So here x is equal to 7 or x is equal to minus 3. Now we have some application level question. See, with the given supply and demand function, see the supply function is given, that is qs square plus 14qs plus 22, and demand function is also given here. So here we want to find out the equilibrium level of price and quantity. And in equilibrium, as per the theory, the quantity demanded is equal to quantity supply. So we are assuming that quantity supply is equal to quantity demanded, which we are denoting in terms of Q. So here the first term will become, see, it is Q square. Instead of Qs, we are substituting it is Q. So P is equal to Q square plus 14Q plus 22. Similarly, the demand function will become minus Q square plus 10Q plus 150. See, instead of QD, we are substituting here, it is Q. Now we can equate the both term, that is quantity demanded is equal to quantity supply. So here it is Q square plus 14Q plus 22, which is equal to minus 2Q square minus 10Q plus 150. See, by rearranging this particular equation, we can write everything into the left side of the equation. So it is equal to Q square plus 14Q plus 22 plus Q square plus 10Q minus 150. If you go for simplifying it, then it will become Q square and Q square. It will become 2Q square plus 14Q plus 10Q, which will become 24Q. 22 minus 150, which is equal to minus 128. See here, we have a quadratic equation. We are just simplifying it by dividing the both sides of the equation by 2. Then the equation will be simplified as Q square plus 12Q minus 64, which is equal to 0. Now this is the simple quadratic equation. We can solve this equation by using the quadratic formula, that is minus b plus or minus root b square minus 4ac divided by 2a. Here a is equal to 1, b is equal to 12 and c is equal to minus 64. So here we are substituting everything here. So it will become, see, minus 12 as it is. Then under root 12 square, which will become 144 minus 4 into 1 into minus 64, which will become minus 256. So here we have minus, so it will become plus. So Q is equal to minus 12 plus or minus 144 plus 256 divided by 2. So if you go for adding these two terms, then it will become 400 under root 400 divided by 2. Then under root 400 is nothing but it is 20. So the equation Q will become, see, Q is equal to minus 12 plus or minus 20 divided by 2. So which is the minus 12 plus 20 divided by 2, which is equal to 8 divided by 2, which is 4. Similarly, minus 12 minus 20 divided by 2, which is equal to minus 32 divided by 2, which is minus 16. So see here, we are not going to consider the Q is equal to minus 16 because it's showing that output is minus. which we are generally not considered. So we are ignoring Q is equal to minus 16 and the equilibrium level of output then, or equilibrium level of quantity, then it will become, it is Q is equal to 4. So output is here, it is 4. Now we can find the price if you go for substituting Q is equal to 4 on any one of these equation. So it will become P is equal to, see, I am substituting here, it is Q is equal to 4, then it will become Q square, that is 4 square, plus 14 into 4 plus 2, because I am substituting this on the equation number 1. So it is Q square, that is 4 square plus 14 into 4 plus, it is 22. So it is the 22, it is 22, sorry. So it is 22. So it is 16 plus 56 plus 22, which is equal to 94. So here the equilibrium price is equal to 94 and equilibrium quantity under this particular market situation is equal to 6. Now let us consider the last one. See, the demand and supply of goods of an industry is given by PQ, which is equal to 100, and 20 plus 3P is equal to Q. And we want to find out the equilibrium price and equilibrium quantity. So here, whatever the information given here, see, PQ is 100, then 20 plus 3P is equal to Q. So here we want to start by using the substitution to solve the system of linear equation. So we will solve this equation. See, the equation number 2 for Q. So Q is here directly given. We will substitute this Q is equal to 20 plus 3P on the equation number 1. Then it will become, see, PQ, first equation number 1 is equal to PQ is equal to 100. Then instead of Q, I am substituting this particular value, that is 20 plus 3P. It will become P into 20 plus 3P, which is equal to 100. If you go for opening this bracket, then P into 20, which is 20P plus 3P square, which is equal to 100. If you go for rearranging this particular equation or subtracting the both side of the equation by 100, then it will become minus 100 here, which is equal to 0. So 3P square plus 20P, which is minus 100, which is equal to 0. So here this is the quadratic equation. So here the value coefficient of x, P is equal to 3, then B is equal to 20, C is equal to minus 100. Now we can use the quadratic formula for solving this particular equation. So P is equal to minus B plus or minus under root B square minus 4AC divided by 2A. So we can directly substitute here A, B, C values so that we will get minus 20 plus or minus under root B square, that is 20 square minus 4 into 3 into minus 100, which is equal to whole divided by 2 into 3. So here minus 20 plus or minus this particular value will become, see, 20 square, which is 400 plus, see, here and minus and here also minus, so we are putting the plus sign, 4 into 3 into 100, which is equal to 1200 divided by 2 into 3, which is equal to 6. So here if you go for simplifying it, P is equal to minus 20 plus or minus under root 1600 divided by 6. The under root 1600 is nothing but, see, here it is 40. So minus 20 plus or minus 40 divided by 6, which will become, see, P is equal to minus 20 plus 40 divided by 6. So minus 20 plus 40, which is equal to 20 divided by 6, which is 10 divided by 3. Similarly, P is equal to minus 20 minus 40 divided by 6. So it will become minus minus. So here minus 60 divided by 6, which is equal to minus 10. So the P is equal to here, it is minus 10. If P is equal to minus 10, that means it is price is negative. So we are not going to consider price is equal to minus 10. We are considering P is equal to, that is 10 divided by 3. We are going to substitute P is equal to 10 divided by 3, see here on the equation number 2, so that we will get the quantity demanded in the market. So P here it is 10 by 3, we are substituting on the equation number 2, then we will get the equation number 2 is equal to 20 plus 3P, which is equal to Q. Substituting here, then it will become Q is equal to 20 plus 3 into, instead of P, we are writing it is 10 divided by 3. So here 3 and 3 will be cancelled out. So what is remaining? It is 20 plus 10, which is equal to 30. So here the quantity demanded is equal to 30. So in this particular example, see the equilibrium price is equal to 10 by 3 and equilibrium output or the quantity demanded in the market is equal to 30. So let me conclude here. Today we have discussed how to solve the quadratic equation by using the quadratic formula. I hope it was clear to you. In the next lecture, we will discuss the another method for solving the quadratic equation, that is the method of completing squares. We will see in the next lecture. Thank you.